All right, in Learning Target 13, we are just taking what we've done all unit long and putting it together in real-world situations. We did that in Learning Target 11 already, right? We did word problems, graphed them, found maxes and mins. Now we're just going to be working with equations. We've worked in 1 dimension in this unit, 2 dimension, and 3 dimension. When you're in 1 dimension, there's only 1 variable. So with a word problem, that would be where you only have 1 variable, then you only need 1 equation. If there's 2 variables, we're in 2 dimension. So if there are 2 unknowns, 2 variables, you got to have 2 equations. And then, of course, if there are 3 unknowns, we're in 3 dimensions, and you're going to need 3 equations. All right, so this first page of the notes is all about 1 and 2 variable problems, 1 dimension and 2 dimension. So number 1, all right, we're going to get to talk just a little bit about ACT here for a second, too. I have 2. I actually have 3, but we'll leave the 3rd one off for now. But I have 2 rules for any geometry problem in ACT, and they're easy to remember. And you're going to get tired of hearing them all year. This is just the first time you've heard them. Rule number 1, no picture, draw one. Rule number 1, if there's no picture, draw one. Rule number 2, if the picture's not labeled, label it. There's a reason they didn't give you a picture, and there's a reason they didn't label the picture, because it's going to make the problem very easy. Okay? So in number 1, if the perimeter of a square is 48 inches, what is the area of the square? That should be a question mark there. Sorry about that. Rule number 1, draw a picture. Draw a square. Do the best you can. Good enough. There are 2 sets of directions from here, though. I'm going to require that you write an equation to model the situation and solve it. I know some of you can look at this problem and just think it through and you can figure it out. You got the solve it part. I want you to be able to model it as well, okay? So if we're talking about the perimeter of a square, we're talking about all the sides of the square being added up. And if we don't know what those sides are, that's where the variable comes in. And the fact that it's a square means that all the sides are the same, right? So the variable x will represent one of the sides, but because of geometry, a square has the same length on all sides. They're all x's. So your equation to model this situation, add all of your sides up, x plus x plus x plus x, 4x. That equals your perimeter, so it should equal 48. That's your equation to model the situation. Divide by 4 and x is 12. That's what those of you who already knew the answer in your head, that's what you did, right? You took the 48, you divided by 4. Okay? But now, what's the area of the square? Area is length times width, or side times side. So 12 times 12, 144 inches squared. I'll throw a disclaimer out there. These are going to be multiple choice, some of them. Okay? And I can guarantee you that 12 will be a distractor. One of the 4 ABCD options will be 12. Would it be tempting to circle 12? Maybe. I don't know. Just be careful and make sure you read the problem carefully. Okay? All right, number 2. Number 2 could be a 1 variable or a 2 variable problem, but we're going to try to make it a 1 variable. If you can make it all 1 letter, make it 1 letter. All right, so that's what we're going to try. We've got a rectangle, so rule number 1, we draw a rectangle. The length of that rectangle is 1 less than 3 times the width, 1 less than 3 times the width, and the perimeter is 70. What is the area? Well, when a problem does something like this, it talks about 1 variable in terms of the other. It means you can do this. If the length is being compared to width, you don't need a letter L for length. You just need a W, because you can write the length using W. 1 less than 3 times the width. That would be a 3W minus 1. So you don't need an L. You don't need a length variable because you can write it with W's. Make sense? All right, finish labeling it. The other 2 sides. W over here, 3W minus 1 over there. And then the fact of a perimeter being add up all the sides from geometry. You add up a W plus a 3W plus a W plus a 3W. So how many W's? 8 W's. A -1 plus a -1 minus 2. And that perimeter, as an algebraic expression, equals 70. There's your equation that models the situation. Now solve it. Add 2. 8W equals 72. Divide by 8. W is 9. Here's a multiple choice question, right? There's a multiple choice, and there's the option A, 9. It's tempting to circle it, but is it right? No, we got to find the area of the rectangle. Area. So length times width, that means we need the length. The length is 3 times W, so 3 times 9 minus 1 is 26. So your area is 9 times 26. I think that's 234. Is that what it is? Okay. 234. Notice the two distractors, A and B, they were 9 and 26, right? Other numbers that you got in the middle of the problem, the ACT is going to do that. Just be careful. That's why a lot of students walk away from an ACT on the math part and felt like they did really well. Then they get their score back and they're like, what happened? It's because they circled distractors. They got answers, but they got distractors. Okay. All right, moving on. I'm not going to solve the rest of these. I'm just going to help you write them. The homework, you'll need to solve them, and if we need to talk about it tomorrow, we will. All right, but I think the harder part of this target is just writing the equations, not the solving it part. All right, so we move definitely into 2 dimensions, number 3 and number 4. So take a second and read number 3. And I'll pause the video. Go. All right, so you've read it, and we just talked a little bit while we paused the video, but we're in 2 dimension because there's 2 unknowns. And if you'll look at the question, like at the very end of the problem, they ask you to find something. That's where you're going to find your variables. They ask you to find the price of a senior citizen ticket, so we'll call that X, and student ticket, we'll call that Y. You might want to use letters like C and S. C for, I'm sorry, no, this wouldn't work really well. Senior citizen and student tickets, I'm probably going to go X and Y. But you might want to pick variables that represent the next problem, vans and buses. You might use V and B for vans and buses. But anyways, that's beside the point. You got 2 variables. That means you must have 2 sentences, 2 equations. The first one, 4 senior citizens, 5 student tickets, $102. Second sentence, $126 for 7 senior citizens and 5 student tickets. I don't know if you need concrete examples or not anymore. Can you write an equation for that first sentence? Four senior citizen tickets and 5 student. Well, let's think. If a senior citizen ticket's $10, what are you going to do with that 10 for the sentence 4 were sold? $10 senior citizen tickets, what are you going to do with that 4? Aren't you going to multiply 4 times 10? Okay. What if student tickets were $20? You take 5 times 20, right? All right, so the equation is 4 times X plus 5 times Y should equal $102. The second sentence, 7 senior citizen tickets, so 7 times X plus 5 times Y equals 126. And I'm not explaining that in great detail for this reason. We've already done these similar in Learning Target 11. We spent a lot of time with concrete examples, and I think you're starting to feel comfortable with that. I hope. Okay? So I'm going to pause the video again, and I'm going to let you read the next one. We're supposed to finish this for your homework, and you will later. But I want you to read number 4 and write its equations, okay? And we'll finish them for homework in class tomorrow. We'll finish the problem later. All right, so I've got a few marks on the question here. I'm going to use V for how many students a van can carry, and I'm going to use B for buses. And then I've highlighted the 2 phrases that put those together. If you have 16 vans and 8 buses, you carried 752 students. So that would look like 16V plus 8B equals 752. The second phrase, 5 vans So 5v, 5 times v, plus 5 times b should be 380. Is that okay? Am I going too fast? That's okay? All right. Moving on, we're going to do at least one more, maybe two. We move now into the 3 variable situations, into the 3 dimension. So we're going to have 3 unknowns. You have to have 3 equations. You can't solve for 3 unknowns without 3 equations. So here we go. The sum of 3 numbers is 18. I'm going to highlight that phrase. It sounds like one of those sentences. The sum of 3 numbers is 18. The sum of the first and second is 15. That's another phrase. And then finally, the first number is 3 times the third. All right, so we're going to call the first number x, the second number y, and the third number z. So dealing with the first sentence, what would the equation look like? Well, the word sum just means add them up, right? Sum means add them up. So if you're adding all 3 of them, x plus y plus z should equal 18. The second sentence says if you add the first and the second, so if you add an x and a y, it gives you 15. So your second equation will be x plus y equals 15. And then you've got to have 3 equations if you've got 3 unknowns. The third equation comes from that third highlighted phrase. The first number, x, is, when you say the word is, or the problem says the word is, that's an equals. So x equals 3 times the third. X equals 3 times z. All right, now that's the equations that model the situation. You'd still need to solve them using what we did in the bell work earlier today, right? Now, I'm going to put a disclaimer out there. This is one of the very few examples of where I would actually use substitution in a problem that's 3 variables, 3 equations. And for this reason, if I take that 3z and I put it here, and I put it here, so I substitute it for x, what happens to the first equation? It turns into y plus 3z plus z. There's a 3z here, there's a z there. It turns into y plus 4z. What happens when you put the 3z into the second equation? It's 3z plus y. That creates a learning target 8 with z and y only in it. Okay? All right, so that's where we'll have to stop for today. Bell should have rang, so we'll pick it up tomorrow.